We've been cleaning out a lab so that it can be refurbished so we can teach our students better. And hidden at the back, we found a really long tube which Pete Licence had made to do the barking dog experiment, our favourite experiment. But he'd found that it was a bit awkward to use in lectures, so it'd been forgotten. Barking dogs are usually done in quite a short tube. Bit over 1 metre long, and this one is seriously long, probably 3 or even 4 metres long. So you probably all remember, because you've seen it lots of times on our videos, it's the reaction of carbon disulfide with N2O, nitrous oxide.
So we've got our barking dog ready to go. Let's see if it barks.
So you fill the tube with nitrous oxide gas, add some water, then you pour in carbon disulfide that's a liquid, and then you shake the tube and the water mixes everything up.
And a good mix, so you can ensure that we get all of that carbon disulfide going into the vapour phase, so it'll react really quite quickly with that oxidant, the N2O.
So the water, as you turn the tube, sloshes up and down and acts rather like a piston to help mix the carbon disulfide, which is evaporating, with the N2O, so you get a gas phase mixture. And of course, the more you shake it, all being well, the better it's mixed. So with the first one we tried, what happened was that we were in a bit of a hurry, and I don't think perhaps we mixed it well enough. Because what happened was that when the tube was lit, the first 30 centimetres or so lit up, and the flame was almost stationary. Neil had time to walk away from the experiment. And then slowly the flame started accelerating down the tube. And then surprisingly in the middle, it almost stopped. Might have even gone up a bit. And then it went with a nice whoosh down to the bottom. And it gave a very nice deep note, which those of you who study physics will realize the longer a tube you have, as in an organ tube, the deeper the note. So that wasn't surprising. But what I thought was that perhaps some of the effect that we'd seen was because of the bad mixing. So in some places we had almost too much carbon disulfide. It was rich in fuel, and other places there was a lot of nitrous oxide and not much carbon disulfide, which explained the sort of stop-start of the whole thing. The other thing which you might see in particularly the slow motion pictures, is that the reaction gives out quite a lot of ultraviolet light, which makes Neil's white lab coat fluoresce. It suddenly looks purple, and quite impressively so. I persuaded Neil to clean the tube and try an experiment the next day. Now the reason why it took some persuading is because when the sulfur is formed on the walls, it's initially formed in a form of sulfur that's called plastic sulfur, which is made up of long chains of sulfur atoms which are insoluble in most common solvents. So you can't just wash it out. However, if you wait a few days, then the plastic sulfur turns into so-called rhombic sulfur, which contains S8 rings, which dissolves in all sorts of common solvents. So you just put in a little liquid and you can wash it out in a few minutes. So normally we just wait and then it's easy to clean. But this time Neil was really scrubbing hard. The next day we tried again. He mixed for a long time, and this time the reaction went much better. It still began with quite a slow start, but then it went down more smoothly with some bouncing like we've seen before. Possibly the bouncing again due to the shock wave hitting the bottom, and we got some very nice fluorescence from Neil's lab coat. And the sound was really a very deep vroom. But if you look at the tube, the sulfur is still not deposited uniformly, so I think we got the mixing good enough to get a good demonstration. We didn't get the mixing good enough to get a completely uniform reaction. And I think this illustrates a very important point about chemical reactions, that mixing can be very important for the results. And the bigger the vessel you have, the more important it is to get your mixing uniform, or you can get some very strange results. The second thing was that we noticed something that we'd seen before. The flame shoots along the tube and then suddenly stops and bounces and goes rather more slowly but oscillating.